Hi, this is your host Swapnil Bhartiya and welcome to TFR Let's Talk. Today we have with us Marcus Eagan, CEO and co-founder of Trace Machina. Marcus, it's great to have you on the show.
Thanks for having me.
It's my pleasure to host you here. And since you folks, are coming out of stealth, you're also announcing, your involvement in open source. So there is a lot to talk about there. But before we go into all those leads, let's just start with basics, which is tell a bit about what is Trace Machina all about and what problem you're still seeing in the problem that you want to solve that led to the creation of this company.
So what we're all about is building the tools that help companies building smart machines and ambitious products in general, but we're focused on autonomous machines, autonomous robots. And what we found is that the tools for making like the previous generation of apps, particularly web apps, was ill-suited for meeting the demands and expectations of people working on AI in the physical world, AI at the edge. And NativeLink is the first product that we've offered to the market that really supercharges the engineers working on autonomous robotic systems, on edge AI.
Was the name inspired by Ex Machina movie? And second is that what do you mean by autonomous robots, smart machines? I'm a heavy science fiction movie buff, so
I'm not a movie buff. The name comes from the Latin for pooled machine. So tracere is like the infinitive. Trace is like a past participle, I guess. And machina just means machine. So it's like, we like to tell ourselves that we're pulling machines into the present. We want to be remembered for having pulled machines into the present. So pooled machines in Latin is Trace Machina. But, people pronounce it Trace and people call it Trace, and that's fun. But, and NativeLink is really about a native implementation of a common practice, a common utility in software engineering that's typically been done with garbage collected technologies, but on the vehicles you need native technologies. And at the scale that these companies operate, you need native technologies. Now, an autonomous robot or an autonomous robotic system is really a supercomputer in many ways. It's a coordination of a variety of different systems that exist in the real world, but are not controlled by humans. They're not controlled by humans in the sense that maybe humans coded them up, but they can exist in the world without human intervention. And like some companies have some degree of teleoperation, or they do some training with teleoperation. These systems that we prioritize and mostly work with, they don't have any human intervention until there's a problem. So that, like, you can think of it as like an autonomous vehicle is a great example of an autonomous robotic system. A delivery drone is a great example of an autonomous system. You'll see in LA, there are these small cars that drive around and deliver food to people. Those would classify as autonomous robotic systems. They go to the restaurant, they flap open their mouth, the restaurant drops in the food, they zip off and deliver the food, and they stop at stoplights and they cross the street and they look both ways, kind of thing. But also like a forklift in a warehouse that goes and picks up packages and takes them to people. That would also be an autonomous robotic system. But and also in many cases, phones, watches, that have new capabilities that people imagined before but have never experienced. The development process for getting those to where they need to be is similar to the autonomous robotic systems. So we're not limited to autonomous robotic systems. We're focused on the companies that have the same scale of problems, class of problems. They're pulling down models. They're orchestrating tasks, and they're executing these models in unique ways in real-time systems. That's really where we focus.
The examples of the example you gave them are all, hardware, real physical objects. When it comes to Trace Machina, are you really talking about the physical world, or you're talking about the infrastructure? So I just want to understand, what are you folks doing in this market?
So we build the infrastructure for companies building these products. So there's over a couple hundred companies in our cloud today, and like we don't make any naval vessels, we don't make any drones, we don't make any satellites, but companies use our product to produce these systems. We don't make phones, we don't make specialized chipsets or new architectures for chips, but companies making these products rely on our infrastructure to do so.
Perfect. And now, since you're talking about, that the company's already using it, so can you talk about, if you can drop some names, who are using it, and also what is the scale of when you talk about the cloud-based? Is it your own cloud? Are you leveraging any public cloud? Just talk about your infrastructure that you are creating for other companies.
I'd like to talk about two companies in particular that I think are important for people to understand. One of those companies is Samsung. So Samsung is one of the largest producers, manufacturers of devices. They're one of the largest manufacturers, designers of chips. They are just a very big player in electronics and technology broadly. And so they use us at the OS level for producing production software that goes onto over 1 billion devices. Their scale exceeds the scale of most companies out there. There's a quote on our website about how a principal engineer took their longest builds from 2 to 3 hours to 1 to 2 hours. 2 to 3 days. Sorry. The principal engineer on their website said we took their longest builds from 2 to 3 days to 1 to 2 hours. You can imagine what the impact of that productivity boon is for that business. And they have lots of different devices to evaluate on, and form factors, and sometimes, different keyboards, multiple keyboards for every state in India, for instance. And the things that Samsung is doing in the future, they're exciting. Trust me. Now, another company I'd like to talk about is a company called CIQ. CIQ makes a Linux distribution called Rocky Linux. The company was started by one of the co-founders, one of the co-creators of CentOS. CentOS. It's like the community distribution of Red Hat Enterprise Linux. And so after the IBM acquisition of Red Hat, CentOS went away. There was a gap in the market for this software. Rocky is one of the co-founders of CentOS, but he passed a few years ago. His co-founder created CIQ and Rocky Linux, and Rocky Linux's adoption has been explosive. Particularly in the semiconductor market, the high performance computing market in general, biological computing, it's very popular. Financial services, it's very popular. And the company CIQ relies on NativeLink because they have to test and evaluate on a variety of devices, specialized hardware. And they also have a quote on our website. And so these companies, when people hear that these companies are using our system, second largest smartphone producer, the fastest growing Linux distribution in a couple decades, and then we're in stealth, it's because these companies had the problem that we solve. And so we're in stealth, but we're open source. And so it's just about getting high fidelity feedback from customers that know they needed our system. So it was a needs-based conversation, a value-grounded conversation, and we got really, really strong partnership out of those companies, and many more. These are just two I like to highlight because they're awesome.
Now, can you also talk about one more question was about infrastructure side?
Yeah, that's right. So we tell people, like, our goal for autonomous robotic systems is for people to, when they're developing, not to think about where things run. It's like you have these requirements. You want this instruction set, this amount of RAM, this many CPU cores. Provide those details, and we'll run it wherever. Like if you have certain latency requirements, we'll run the system very, very near to the client. The server will be very near to the client. And so we have like a lot of interesting ways that we accomplish these things. We can run, so all the public clouds we can run in, we can run in some private clouds. We run in a lot of private clouds today.
What was the reason that led for you to create NativeLink as an open source project?
Today, we work with some of the biggest companies in the world by market cap and by impact and by value and to the world. And those companies cannot be locked in under any circumstances. There's like a business continuity equation that they have to evaluate whenever they adopt a new technology. And those companies, 10 years ago, they were like, no open source. And today it's only open source. And so it's just, people have realized that open source is just like a way to ensure that the code has been audited, a way to ensure that you can run this code if something happens to the company behind it. It's a way that you are empowered to run a system where you need to run it and how you need to run it. Some of our largest production users have never talked to us. Not on the phone, maybe we've exchanged a message here and there, but they've never hopped on the phone with us. And that's okay, because we're in it for the long haul. I mean, the multiple decades haul, just to quantify long there, So, and this also, my whole career has been in open source. Most recently I worked at MongoDB, and at MongoDB is open source, and I led a product that was based on another open source project that I had been working on outside of MongoDB. And at one point I was the only person at MongoDB who had contributed to that project. And so it's like, I wouldn't be where I am, we wouldn't be where we were if open source didn't exist. I didn't have a lot of money when I got started in my career. And open source empowered me in so many ways. I've worked with developers all over the world, and it's empowered them. And one thing I can say about everybody with respect to open source is that we all benefit more than we contribute.
what kind of community you are planning to build around it? Is it going to be, as you said, rightly, that most of the contribution is at this point coming for the company, but are you also like looking for contributions, or you're like, hey, this is an open source project, if you feel like, you will pitch in and contribute?
Yeah, we've got a lot of contributions from outside the company, but I was saying the majority is inside the company, and I think the contributions from outside the company are obviously a lot more valuable because they're in our customer companies. Like, so we really benefit from that. They help us be successful there, but we also learn more about the challenges that they are encountering, which may be consistent beyond only them. Now, now, like, we have enthusiastic community members. We have folks from Central Europe, from the Middle East, from Pakistan, from Japan, from Australia, New Zealand, the United States, South America, the UK, I mean, all over the world. Germany, many people in Germany. And we know that we're not worth much without them, because an open source project with no community is just code.
Is NativeLink or Trace Machina playing any role in autonomous vehicle space as well? And if yes, what is that?
Yeah, so we are. Uh, I would say that we don't have permission to talk about too many of the autonomous vehicle companies. They don't let us. And some of them don't tell us. I mean, most people do tell us though, but like, yeah, they don't allow us to talk. I think one company, I mean, we have contributions to our project from Cruise and from Tesla. That I can say. And from other companies in this space. The role is that there's a very expensive part of all of these businesses, and we make it less expensive, a lot less expensive. In some cases, we've dropped the cost down by 98%. In other cases, it's like 50s or 60s or 70s. But the unit economics of these businesses does not make sense. People will stop investing in them. They'll stop working on them unless there are new tools that make these systems economical. You can think back to the car. The car wasn't invented, the automobile was not invented by Henry Ford. The assembly line was invented by Henry Ford. And so he made, in his company, the mass production of vehicles economical. And growing up in Detroit, I saw this effect firsthand. I worked at Ford Motor Company. I worked with pretty much every automaker, all the major ones in my career. Oh, in various ways, but I was an employee at Ford Motor Company, and I saw what it means to have been an innovator and economizing a complex process and scaling it. And so now we have this new paradigm of like a new category of product, a new type of product that people don't see on shelves yet. You can't go to a dealer yet. If you live in San Francisco, Los Angeles, or Phoenix, you can hail an autonomous vehicle pretty easily. But like, autonomous robotic systems are not in everyone's minds all the time yet. And part of the reason why is because we haven't come to economize the production of them yet. We have lots of companies on the cutting edge doing amazing things. I I mentioned over 200 companies in our cloud. Well, our product is not only useful for autonomous robotic systems, though. Like if you're building a mission critical system, right? Like, because you can even take the example of CIQ. Like Rocky Linux isn't an autonomous robotic system in and of itself. It is used on them a lot, a whole lot, because of the business continuity conversation we had earlier. But if you work on mission critical software, really complex code base that's large, mixes in a lot of native code, or is built on a lot of native code, we're probably going to be an accelerant for you, an economizing force. Like a lot of native mobile apps use our system too. Um, but yeah, that's like we felt like if we solve these problems for these massive systems, then these other large systems or complex systems would be things we can handle. And that's why, we're very proud of the work that we've done with Samsung.
Can you also explain how does either NativeLink or Trace Machina help actual engineers, irrespective of whether we are looking at autonomous vehicles, robots, or just systems?
Yeah, yeah. It's, the simple way is remote execution and remote caching, right? So when you have a large system, a complex system, typically what companies would do is they would ship out a bunch of GPU workstations for the engineers to put them under their desk. And at a certain point, that became less economical and less efficient. And there was a paradigm that came out of Google where people started to share resources. So my co-founder comes from Google, and he built a remote cache that allows everyone in a company to just consume the same cache, just work on the same cache. And that's step one. And so when you have that figured out, then you can move to remote build execution, right? And so now we're talking about running the workloads on the hardware that will be used in production for these companies. It's a big productivity boom. The flakiness goes away, the reliability of the test, you can rely on it more. Trustworthiness, like that is a big step forward for a lot of companies. And the hermeticity, for robotic systems, reproducibility is also very important. You want consistent behavior of the system. And then beyond that is because of the architecture of our system, through the use of NICs and Rust, we are able to reliably handle the movement of large binaries, large assets. And so that is of critical importance for these companies that have these low latency requirements or that have the large training sets, large training data, or these images or these video streams that 30 frames per second. Like we need to be robust in our approach to moving data between different systems. And I think that NativeLink is very good at that. I tell people it's like it's a high performance DAG. So like job orchestration, model execution, you can think of like low level implementation of Apache Airflow, which I've worked on. I've worked on that system as well. Small, long time ago, maybe like 5 or 6, many years ago, but 8 years, something like that. But like, this is the goal for us: is to be the the system that's built for speed for the people that need it.
And Marcus, can you also talk about, when you're talking about, whether it's autonomous car or any other, as you mentioned, it's not just autonomous vehicle or robots, even mission critical. We have learned a lot of lessons, don't do a lot of things in production. So talk about the role and importance of simulation infrastructure, how it enables engineers, companies to run their software test, not in production, but do all the tests and see the results as they want.
Yeah, so we just started working with a database company that I worked with previously, MongoDB. And MongoDB can use NativeLink to simulate a very large, first of all, a very large test suite. Like they can run all their tests on all the hardware they need to support. And they have to support a lot of hardware, as you know. But taking it a step further, they could also simulate load or simulate fault in ways that are very useful to that business. And there's a lot of tools out there that do that, but they're not native and they're not open source. And so we have new capabilities we can introduce because of those facts. We are the native link to reality in simulation. Like we're closing the sim to real gap because you don't want to get into a plane where the software has never been tested. You don't want to be the test flight for new avionics systems. You want those to have been vigorously tested for years. You don't, or for months at least. You don't want to put your transactions for your bank onto a database where transactions were not tested at that volume. And so we spent several years, many people on the team have been maintaining open source databases for a long time. From Apple, from Google, as I mentioned, Cloudflare even, scaling really large systems. So yeah, we want to engender confidence in companies when they go to market with their products. I mean, one of our employees, he always likes to talk about regulators. I don't want to talk about regulators, but he's like, we have to show the regulators we ran all these tests. Really, really tried to do the right thing.
Talk about your long-term plans and your immediate short-term goals that you have right now.
Our long-term plan is to show the world that we're all in it together, that we can be open source and build a viable company and help people build the future of technology in collaboration. We think it's very important for AI to be open source and driven by open source. I think that long term, we want to have an impact on every continent. We want to have a presence on every continent, and we want to work with people all over the world. And for most of that work to happen in space. But in the short term, we have a few goals. First goal is we want to get 100 companies to production. And that's the next few months even. Because we have so many companies in our cloud, we have so many companies in our open source that are in production, but we want to get them to production, make sure that their lives are actually being improved. Like our hypothesis is being validated even further. We also want to quantify the impact that we have on reducing carbon emissions and energy consumption. Because one of the big issues with the legacy systems is they flake all the time. And so a lot of times people think, oh, this is my code. Like this is a flaky test because I wrote it poorly. It doesn't look flaky, but it's flaking, so I must have done it poorly. Well, maybe the test harness may have been the issue. Maybe these expensive mutexes and these locks, they didn't behave as expected. And so one of the big benefits of our system that people always come to us and talk about and rave about is like stability. Like stability of our system is really the value that they got from it, and reducing flakiness in their system in ways that they thought were on them. And so we want to show the energy impact, because where we have to go as a species requires a lot more carbon consumption than we can provide or than our grid can handle. And so we, as a part of building our business and being infrastructure for the next generation of technologies, we think it's incumbent on us to be more efficient, more energy efficient. And so that's number two. And then number three, that we think is really important is we want the 10,000 startups that emerge over the next few years, or the most ambitious existing companies, large enterprises, we want them to go fast. We want to supercharge those companies. And that, like I talked about 100 in production in the short term. This is short term too, but it's like 6 months out, like 6 to 12 months out. Like in 12 months, we hope 10,000 companies are feeling the jolt of energy that companies get when they adopt NativeLink. I mean, we have a public database companies, like we didn't even know this was really how things were supposed to run. We didn't know that we don't have problems with these tests. We don't have problems with these tests. We formulated all these different theories and ideas on what the problem was, when in fact it was the underlying infrastructure. And so that's where we want that aha moment to happen for as many builders as possible, so that we can progress as a species.
Marcus, once again, thank you so much for joining me today, and of course talk about the company, the open source project, and also the reason why you're doing this. Thank you so much for great insights, and I would love to chat with you folks again as the company and the project makes more progress. But I really appreciate your time today. Thank you.
Thank you, Swapna. I really appreciate it. It was a pleasure.